Hey everyone, welcome back. My name is Andy. I do some streaming on here. Well, I did some streaming on here a couple of years ago doing Python-based streaming around Nest development. So for anyone that's returning from that, welcome back. I figured it's been a few years since I've kind of messed around with that, so I'd kind of jump back into it and do some work on making a roguelike. So yeah, what's the point of this? What am I doing here? So I am looking to just kind of brush up on my Python skills, use the new Python features, the Python 3.7 in particular, and to make a roguelike, which is just a type of game. So I guess to start off, yeah, let's just talk about what a roguelike is and what a roguelike is not. So just going by the Wikipedia page, we've got this roguelike page here. We can kind of see what is it, what they look like. What if I search for roguelike and give you an image? So this is what your typical roguelike looks like. It's kind of all made up out of text, 2D top-down view, and the point of it is kind of forget about the graphics. It's all about the gameplay. And it's all about what you can do and how much of it you can do. So it's kind of a cool idea, particularly for Python, because it's going to allow us to mess around with some of the new features in Python that I really want to try out, like the typing system and the new data classes. I want to mess around with some entity component systems as well, and make something that's super configurable. So that's kind of the basics of it. So what makes a roguelike? So it kind of looks like something like this, and there's a definition somewhere in here which kind of gives what are the key features of a roguelike. So typically the main thing that people think of when they think of roguelikes is permadeath. You will run through a dungeon and then you'll get to a certain level, you'll hit a point where you die, and once you die forever. So you create a new character, you come back from the start, you've lost any progress that you've made, any items that you've picked up, anything like that. The second one is that it uses random dungeon generation. A lot of that is kind of something I'd like to explore, and how we could use random generation to generate levels. The game is turn-based. Potentially this may not be true. This game might be turn-based or real-time. I haven't really determined there. The rest of these, I think, are less important. I think they're kind of the main things to me are the random generation and the fact that you have permadeath. Cool. So what I'm going to do now is just do an intro, particularly focusing on Python. So it's been a while since we've done a Python project, and I just thought I'd do an intro on, well, how does Python work? What has changed since we last did it? And just kind of a high-level overview of how I'm going to set up a new project completely from scratch. So I might just dive into that and just give an overview of what is Python, what are the different versions of Python, how can we set it up, things like what is a virtual environment, what is pip, what is Python 2 versus 3, so on, because I know those kind of questions are pretty confusing. So just to start off, I guess, if you're watching this stream and you're coming from the Python community, I guess you know what Python is, but at a really high level, Python is a programming language which has been around for a long time. So the reason that this comes up is that the Python community is divided kind of into two parts. So we've got Python 2 and Python 3. So basically, if you've been programming Python for a long time, you would have started off programming in Python 2. Python 2 is a great language, but it's kind of at the end of life now. So typically what you'll find is that people recommend you use Python 3 if you're new to Python, if you're starting a new project, if you're doing anything like that. So what are the kind of differences between these two things, Python 2 and Python 3? So at its very core, Python 3 is the modern new Python that is being developed. So Python 2 is supported with bug fixes and stuff like that, but there are no new features being added to it. There's nothing that's kind of coming down the pipeline, and it's all kind of Python 2 is essentially a dead language at this point. So I believe that it stops support in 2020. The start of 2020 is when that language dies, which is actually not that far away. So Python 3, what's kind of cool about it? What are some of the new features that people use? Speed. So one thing that I think is a lot different from Python 2 to Python 3 is it's just faster. It's faster to do things. It's faster to run stuff. It's just kind of something that's out of the box and nice to have. Consistency. So one of the big differences that people find between using Python 2 and Python 3 is that a lot of the language feels a lot more consistent. A lot of the things that you do in Python 2, you'll hit an edge case and the syntax would be weird, or the way you had to do it is weird. So some classic examples of that, like when you create a class in Python 2, you have to inherit from the base objects class. You don't have to do that in Python 3. In Python 2, there's a max size for integers. There's not in Python 3. Python 2 doesn't support Unicode correctly. Python 3 does. Stuff like this. So it's not stuff that you kind of notice too much day to day once you've moved to Python 3. It's more something you notice if you've been on Python 2 and, coming up against all those edge cases that is kind of solved for you in Python 3. One of the cool things that I really like that I've used in past projects is typing in Python 3. So they've added an optional type system. So what this means is it allows you to declare variables or parameters with types. So you can say, all right, I'm getting a number of steps variable passed in, which is of type integer. Or you can say, all right, I'm getting a character name passed in, which is of type string. So it's what I guess is called weak typing, which means it's not actually enforced at runtime. So Python is still like Python. There's no restrictions on what data you can pass around where, but it does make, I think, the code more clearer, easy to read in certain things, and also will throw a warning at you if you're doing something that's obviously wrong. One of the other things that Python 3 has is new language features. So we'll kind of come up against some of these, but these are things like F string interpolation. So you can do, my syntax is going to be wrong, but hello, and then put a bracket, name. So you can do stuff like this now, where you can do insert someone's name into here, where this is a Python variable. I should chuck this across here a little bit so it's not hidden. So you can kind of do like a string interpolation, which is obviously quite useful. There are some other language features. Data classes have come in, which I'm really excited to use, which basically are, for those that have used Python 2, is kind of like a really nice built-in wrapper around named tuples. So it allows you to create a class that just stores data without having to write like a init and self.x equals x and getter and setter functions and this kind of stuff. It just kind of does all that for you. There's plenty of other like language features that we probably won't hit up against, like async IO and like a whole new support for how they do asynchronous programming and stuff like that. That's less important. I'm not worried. Everything to do with meta classes and like how the class inheritance chain works is all simplified, cleaned up, worked correctly in Python 3, which is great. So let's move on from that. So basically what the point of this is that Python 3 is A, where all the features are, B, it's the faster one, C, it's what is supported. So we're going to use Python 3 here. If you're starting a new project, you should be using Python 3. One of the next things I want to talk about, let's save that. Sure. One of the new things I want to talk about is, all right, well, what are the difference between Python versions then? So you have 3.4, 3.5, and 3.6, I believe, are the two. Oh, I know, and 3.7 just came out. So probably 3.4 is not supported anymore. 3.5, 3.6, and 3.7 are the latest Python versions. we are going to be using 3.7. That is the latest version. It's kind of what you'll get if you just download a copy of Python. One thing that I'm going to use here, which is really useful, is something called pyenv. So what do we need pyenv for? So the basic idea is that if you do, like if you're on OS X like me, and if you do a brew install Python, it will install the latest Python, which in this case will be Python 3.7. That's all well and good, but you might decide later that you have another project that you want to run on Python 3.5 or on Python 3.8, and those two things might not be compatible. So you might need to have multiple versions of Python installed to be able to run different projects, or you want to try out the new features but still have the old version of Python kept around for stuff. So what pyenv allows you to do is manage installing and removing and all that, these different Python versions. So instead of doing a brew install Python, we're actually going to use pyenv to do that. So I'm going to take you through the whole process from start to finish of let's create a Python 3.7 install using pyenv, and then we're going to go into virtualenvs and pipenv and various things. Oh, that didn't work. Sure. All right, so pyenv, which is forked from rvenv, which is basically the same thing but for Ruby, which I've used and is super useful. So, give me a second over here. There we go. So how do we install this? We will installation. I am on OS X, so I'm going to install it with Homebrew, but there are other projects that will install it for you if you're on Windows or Linux or something like that. You can also kind of download the source and so on. So what we're going to do is, now I actually already have this installed, but I'm going to do it as if I do not. So we do a brew install pyenv. So again, this is just going to install the tool that's going to allow us to install different versions of Python, and then we're going to use that to install the latest version of Python, which is 3.7. So I believe we do a brew install, and then it says follow the rest of the installation steps starting here, starting with number 3, which is this step here. Cool. So Homebrew is going to update, and then it's going to install that. So while that's kind of going, I guess it should be pretty quick because I actually have pyenv already installed. I guess I can just talk about what we're going to be doing next. So we're going to install Python 3.7, and then we're going to go into, well, what is a virtual environment and what is pip and all those kind of questions. Python has changed a lot over the past couple of years, and the knowledge that kind of what was best practice a couple of years ago is not necessarily best practice today. So I'll just go through how do we do, what is the best way of managing this kind of stuff. Great. So you can see I now have pyenv installed. We need to make sure that eval pyenv init is placed towards the bottom of the shell configuration file. So what this says is echo this command in here to your bash profile. So it's saying add these lines to your bash profile, and what that's going to do is they'll get loaded every time you open up a terminal. So I have actually already done that. I've run that command now. I just copied and pasted that in. But I'll show it to you. You can kind of see I've got some other stuff in my bash profile around Ruby and Postgres and stuff, but this is the important line. This is what this command does. It adds, if it can't find pyenv, then evaluate begin pyenv. So you just copy and paste that command into your shell. Restart your shell so that the path changes take effect. Cool. So I have already done that. So now what we can do is we've got pyenv. And this is going to tell us some things, and we can see pyenv versions. we've actually got system and we've got 3.7. So I'm just going to do a pyenv install 3.7 again, just so you can kind of see what command you would type if I hadn't already done this. So continue with this installation. So I'm going to say no here, but essentially all this would do is install Python 3.7.0. Great. So now we've got an install of Python 3.7. And we actually want to use that now to create a project. So there are two ways of doing project management, dependency management in Python. Well, there are probably more than two ways. There's old ways, there's setup tools and easy install and stuff like that. But there are two ways that we really care about. One is what I'm going to call the native way. And one is something new, which is called pipenv. So what is the native way? So the basic concept behind Python packages is that we do not want to install a Python package for a project on the global Python version. So the reason that we would want to do this is, say we have two projects, one of which requires requests, which is a kind of a classic library, requires requests version 1.0, and then we have another project that requires requests version 2.0. Those two things might not be compatible. One might need it for legacy reasons, one needs the new one because it wants to use the new features. So how do we deal with that? So the answer in Python traditionally has been something called virtual environments. So a virtual environment is essentially just a new version of Python that you can install dependencies into. So to kind of take a really high level view, all it does is takes the base copy of Python, so we just installed 3.7, and creates a copy of that can have its own dependencies, its own installs, its own stuff. So it actually creates the virtual environment contains a new version of Python copied from that base version. So what you would have is that for each project, you would have a different virtual environment. So each project would have a different install of Python, and they would each have their own dependencies installed on that version of Python. So actually, when you ran those two different projects, they would be running with two different versions of Python, one from each virtual environment. There is a native way to do that in Python, which allows us to create that. So I'm actually going to walk us through this workflow because I think it's important to understand. So if I search for Python virtual environment, they're also called virtual M's or VMs potentially. Pipenv, no, sorry, this one. Right. So if let's go and actually do some code. So we're going to, where am I? Yeah. So we're going to go into my documents folder. We're going to make a directory called rogue. So we're in just a blank folder now, and what we want to do is install a virtual environment, so a new version of Python. So we can kind of see here that there's a command to do that. Just first things first, I'm just going to check that I'm using Python 3.7. So if I type pyenv, I should be able to see pyenv local, or actually pyenv version will tell me which one I'm currently using. So I'm using the system Python, which is not really what I want. So I want to say pyenv local 3.7.0. So what this is going to do is, oops, I should say pyenv. What this is going to do is say in this directory use version 3.7.0. So now when I type pyenv version, it should say 3.7.0. And if I type Python, we can see that we're using Python 3.7.0, which is what we want. So that's great. Exit. So now what we want to do, again, we're in an empty folder. We want to create a virtual environment, which, like I said before, is just a copy of Python. So we can do python -m venv, and we'll call it rogue venv. So all this is saying is to Python, create a new virtual environment and call it rogue venv. what this will actually do is create a folder that has a full Python install inside of it. So you can see now if I do a directory listing, there is a rogue VM folder. I guess if I do that to prove that it's a folder. And we can actually go inside this virtual environment. We can take a look. So what's in here? Bin include lib, blah, blah, blah. So it's actually a full Python install. So if we go into the bin folder, we should be able to see all the Python executables. Great. So you can actually see there's a Python executable there. Maybe if I do this to make it a bit easier to see. So we can see that there's a Python executable here. Now, all it's actually doing is it's like a symlink through to the base Python install. So the virtual env is doing some magic, so it doesn't have to install a full version of Python each time. But this is essentially treated as a fresh install with all the stuff. So if I install a dependency here, it's only going to be installed in this version. So let's do that. So now I'm back in my base folder. You can see I have my rogue VM folder. How do we it's called activating the virtual environment. How do we make sure that we're working in the virtual environment? So there's a script in here in rogue bin activate. This is just, I won't go too deep into this, but this is essentially how you turn the virtual environment on. So how do you start using the virtual environment? Which is obviously useful. So if we do that, you can see now we're inside the virtual environment. We've got this little rogue VM brackets here, which tells us we're in the correct virtual environment. So now when I type Python, I'm in Python 3.7, and it is the Python that is inside that virtual environment. So to come back to here, so we've created a virtual environment. Great. So how do we install a package? So in Python, packages are things you can install like requests library to make HTTP requests, or the library that we're going to use to make our roguelike game, or something where you can use to make audio, so on and so forth. So there's a tool called pip. So pip just manages dependencies for you. So what it allows you to do is say pip install requests, which is the name of a package, and it will install it in the current virtual environment. So if I actually go back into that virtual environment, you'll be able to see pip. So if I go back into the bin folder, you can actually see that pip is part of the Python install. Great, so I'm back in the top level folder. You can see I've got this little thing on here, which means I'm in the virtual environment. So I want to install the request library. So just to kind of verify that we are doing the correct thing, so if I open up Python now and try and import requests, it should error out because we haven't installed it. If I exit and do a pip install requests, then it's going to download requests and it's going to install it in the thing. So now when I do Python and I do import requests, it should not error out. Great. So we've now got a version of Python that has requests installed. And if I get out of this virtual environment, how do I do that? Deactivate, I think. You can see I'm no longer in the virtual environment because I don't have that rogue env next to it. So now if I go into Python, it will be Python 3.7, but it won't be the virtual environment one. So it won't be the one with pip with requests installed. This is my base Python install. So import requests should fail because again we're not in the correct virtual environment. Great. So now let's go to the example of I'm doing some development and I know that I need the request package for this script to run. But I want to share this code with a friend and I want them to be able to run it. So how do I tell them what packages they need to run? This is where the concept of pip uses something called a requirements.txt file. So what we can do, I'm just going to use nano here, which is just a text editor, is we can make a file called requirements.txt. And we can say this project actually needs the requests library. And you can list multiple here, right? Say lib, whatever. Great. So now we've got a directory that has two things in it. It has requirements.txt file and our VM folder. So let's do that. So if I just do a pip uninstall requests, oh, actually, let me just get back into my virtual environment so we're working the correct thing. Bin activate and do a pip uninstall requests. Yes. So now if I go Python import requests, this should fail. So we've gotten rid of requests in this virtual environment, but if you look at requirements.txt, it's going to tell us that requests is the library that we need. So we can use pip to install every requirement that is needed for this project. So we can do a pip install -r requirements.txt. So all this is saying is install the requirements that are listed. -r, I guess, stands for requirements file. Install all the files that are listed in this requirements.txt, which is just a request package. And there you go. You can see I've installed the request package. So now when I go in there, Python import requests, that's going to work. Great. So over here, you've got native. You can create virtual environments just using native Python. Pip comes installed with Python, and then you can use a requirements.txt file. So what is the benefit of doing things this way? So the reason I call it the native way is that they're all native tools. Like pip, the concept of virtual environments comes with Python. The concept of pip comes installed with Python. Requirements.txt is the file that you give to pip. So you don't need any extra tooling. Just using a base Python install, you can actually manage packages using virtual environments really well. So it's pretty simple. So why does this fall apart? A number of reasons, but at its core, it's kind of, one, it's convoluted, right? There's multiple steps. You have to understand what a virtual environment is, and then pip is, and requirements, and keep that in sync, and it's all a bit confusing, right? And that's even before you take into account how this has all changed over time and, you know, different ways of working. There's a good XKCD out there somewhere on it. So what has happened recently in the last, I guess, a year or so, is that a tool called pipenv has come along. So pipenv is made by the dude who made requests. So requests was that library we were just installing. It's a very famous Python library. The guy who made that is very respected in the Python community. He's made this tool called pipenv, which essentially, the concept behind that is, well, what if we took all of this and put it into one package that managed it all for us. So we didn't have to worry about a virtual environment or pip or requirements.txt or anything like that. And it just like handled everything for us. And he did that. And it's called pipenv and it's pretty cool. So I've used it a bit before, but I've never used it properly on a project. So this is going to be one of my first times messing around with it. So yeah, we'll just have a mess around and see how it goes. But that's all the concept of what it's doing. It's just taking that native way of how do you manage dependencies in Python and turning it into a bit more of a polished package. So what are the downside of this? The main thing is that you need to install another tool. You need to install pipenv. Obviously, that's not a huge deal, and I think this is kind of going to be the new workflow for Python development. But, you know, if you don't want to install another tool, which, you know, some people do not want to do, then there is possible to manage all your requirements natively. Great. So, pipenv. Let's take a look at this. So again, I'm just going to install it using Homebrew because I find that a really easy way to install things because I'm on Mac, but I'm sure there's other ways to install this. Cool, so we can just do a brew install pipenv. So let me just get out of that. Brew install pipenv. Now again, I already have pipenv installed, but you know, I'm just going to make my life easier. I'm not going to bother waiting for that to finish because I already have pipenv. Maybe I don't. Maybe it's updating. Oh, no, I have pipenv on another computer. All right, well, I don't have pipenv, so it's actually installing it. Cool. So what are we going to use pipenv for? So we're going to use it to kind of automate that whole workflow around virtual environments and all that crap. Oh, this looks pretty cool. Cool. So what I'm going to do is I'm going to remove that folder, and then I'm just going to redo that whole workflow, but instead of virtual environments and so on, Winderkin, you can use pip to generate a requirements file for you. Yeah, that's true actually. I'm unsure what the command, I guess pip add or something. Some of the workflow stuff around pip, I'm sure, has like been improved over time since I last used it as well. So, you know, feel free to call me out if I criticize it incorrectly. Thanks, Wounded Kitten. But the kind of basic concept is that pip will work off having a requirements file. So you can do things like lock a specific version in there. Ah, pip freeze. Okay, well I might go back and show that actually when this finishes installing. So as Wounded Kitten points out, you can do a pip freeze to requirements.txt installing pipenv. All right. Well, we're getting there. So I'll go back and I'll just show you how to do that with pip, and then I'll move on to what pipenv does for us and how it's kind of hopefully going to be the future. Great. Okay. So we've got pipenv installed. So what Wounded Kitten was pointing out was that if I look at if I'm in my folder and I actually remove my requirements.txt and I do a pip freeze will tell me what versions of software I have installed. I don't have any because I'm not in the virtual environment, so let me go back into the virtual environment. And now if I do a pip freeze, I can see that I have these libraries installed, which are requests and then its various dependencies. So I can do a pip freeze and then pipe the output of that to requirements.txt, which will create a requirements.txt for me with those dependencies listed. There are some kind of downsides to this. It's kind of hard to upgrade things. You can see here that I only installed requests, but it's also listing all its dependencies and so on. Again, there are probably ways around this. So, deactivate. So let's just go up a level. Let's remove that. Oh, just go up a level and then create a new thing. Make dir rogue pipenv. So we're now going to do that same thing, but with pipenv. So we're in an empty directory. Again, we just want to make sure that we're using the right version of Python. So pyenv version. We're using the system version of Python, so we'll just set the local version to be 3.7.0. So again, I'm just making sure that my base install is 3.7. Cool. So now we've got pipenv hopefully installed. Great. Oh my god, colors in my terminal. What's going on? So what we can do is create a new project using Python 3.6 specifically, install all dependencies for a project, do a lock, graph, check. What our basic workflow is going to be is installing pipenv. Let's read the documentation because I haven't used this much. Pipenv install requests. Right. So now instead of doing a pip and having to worry about virtual environments and that kind of stuff, we can just do a pipenv install requests. And hopefully this is going to work for us. Using Python 3.7.0 to create the virtual environment. So it creates a virtual environment for us. Doing some other stuff, creating a pip file. Basically, it's just downloading requests. So when this is done, what we should see so again, what this tool is doing is creating the virtual environment for us, collecting the package, installing it into the virtual environment, and then it's also remembering, hey, what did we install and how did we install it? Great. So now, if you look at our ls, there are two files in this directory. There's a pip file and a pipfile.lock. So let's take a look at those. So the pip file is basically, again, this is all maintained by the package, so we don't need to edit this manually at all, but you can kind of get an idea for what's going on. So what this is saying is just some metadata here around where the package management library is and so on. And it's saying that the only requirement that we have at the moment is the request library, and we've said any version of requests. So if we did like a, pipenv install requests version 3.5.1, it would install that specific version. We don't have any development packages, and this also tells us that the version of Python that we require is 3.7. So this is kind of cool. It tells us that I'm using Python 3.7 to install these packages, so if someone else is coming along here, they should also be using Python 3.7, which is kind of handy. It's also got this thing called a lock file. So some of you might be familiar with lock files from other projects. They're kind of, again, it's an auto-generated file, and what it is, hey, someone's installed this package, and we've said you can install any version of requests. But when I installed it, I installed a specific version, right? I installed version, I have no idea, whatever I did install. URL lib request. I installed 2.19.1. So what this tells the computer is that when I ran it, when I installed it, I installed I installed request 2.19.1. So if someone else installs it, they should be installing the exact same package. So it allows us to lock it to a specific version without having that as a dependency. So it means that if someone else wants to come in later and say, hey, actually upgrade this package to the latest version, they can do that because the request is unlocked. But it also means that when I'm installing it on two different computers, I know that I will get the same file. So the lock file is just what was installed at the time that this was run, so that everyone's on the same version, but it means that we can upgrade it later on. Anyway, that was a bit of a long-winded way of getting to that, but what you can kind of see is that those are two different ways of doing that. So using pipenv, we just use the pipenv install. Pipenv install. And then the package name. And that's going to handle all the dependency stuff for us. So it gets rid of all that. All the other stuff you need to know about. So yeah, that's probably all I'm going to talk about in terms of like Python setup. You can kind of see all I've really installed the two tools, pyenv to manage installing Python 3.7 and then pipenv to manage installing like all the requirements. So yeah, let's go ahead and create a project and like get started. So I'm just going to come out of here and I'm going to remove those two projects that we just made. Great. So I use an IDE called Pycharm, which now has pipenv support built into it. So I'm actually going to use that to create the projects. But if I wasn't going to do that, I would just do exactly what I did there. I would just have gone in, created a new directory and said pipenv install whatever library that I wanted, and that would have created the version of Python for me. So now I'm going to use this using Pycharm, but again, I'm not doing anything special. So let's call our project Rogue, because we're going to make a roguelike. Let's call it Roguelike, because it doesn't know that Rogue is empty. And we're going to create a new environment using pipenv. The base Python version that we want is Python 3.7, so that seems correct to me. So let's hit create. So all this is going to do is install a new, just set up a new project. It's going to create a default pip file and a pipfile.lock without any dependencies. Again, this is just the same as if you do like a pipenv activate or whatever the command is. Great, so you can see, hey, we've got a pip file. Again, doesn't have any packages yet, but it's using Python 3.7. Exactly the same. We don't really need that. So let's create a Python file. Let's call it main.py, because we enjoy doing that. And we're just going to write some Python code. Great. So for those people that are familiar with Python, this is obviously going to be very familiar. It's very similar to Python 2, the only difference being that print is now a function instead of a keyword. So I'm just going to use my IDE to do all the running and stuff, but basically you can see this little arrow means that I can run the script from here and we see hello world. I'm not going to go too much into doing the basics of Python. I've kind of done that in some other videos that I've done, but all this is doing here is saying this is the main entry point of the script. So it's going to run this line by line. It's going to ignore this because it's a function, come down to here, run the thing in here, calls the function, and then prints hello world. So when we print it, we see hello world is the output. Cool. So now what do we want to do? We actually want to make a roguelike. So before I do anything involving graphics, before I do anything involving creating a window, what I just want to do is mess around a bit with this new Python stuff around creating a character, putting them in the middle of the screen, and like seeing what that looks like. So what I'm going to do is I'm going to create a new file and call it a player or something. None of this code will stick around. This is just kind of me messing around a bit with the new Python features and just prototyping some ideas out in my head before we go and actually create the new thing for real. I have a whole bunch of stuff that I want to do around like ideas around this thing, and a lot of it is going to be messing around with kind of more advanced programming stuff. So I might just do before we go too much further, do a new thing and say, all right, well, what are the goals of this going to be? What do I actually want to make here? So I kind of want to make something that is Python 3.7, obviously, that is going to be what I would call using an ECS. So the idea is, instead of having like a different class, we'd have like a player class, which inherits from a unit class, which is how it gets its movement. You just kind of have things that have attributes. So you have like a player might have a movable attribute. It might, or component, it might have a woundable, so it might have HP, and it might have be able to carry items. And the idea is you can kind of mix and match little bags of functionality to make up objects. So like a player is movable and damageable and can carry items, so on. Whereas a backpack can carry items but can't be moved or damaged, so on. I want to make it event driven. So one of the cool things I really want to try out is doing a bit more like functional programming, and particularly with having hopefully everything be driven by events. So instead of kind of having classes that mutate state, what I'm hoping is that everything are just bags of data that get mutated by an event. And then the idea being that if you can mutate forward by an event, you should be able to mutate back by an event. So kind of that's a long-winded way of saying is that hopefully what I'm hoping to be able to do is to be able to rewind time and move forward in time, because everything should just be a bag of data that can be passed through a mutation or an event, and then you should be able to roll that event back. So everything should be reversible and non-reversible. I kind of want to do a separation of what I would call a separation of concerns, but a separation between rendering and data. So ideally, I want to be able to plug any front end into this. I think it's going to be like a ASCII front end. like what I kind of showed before, but you know, whatever, you should be able to plug any graphics library into this and it shouldn't affect the input and the output, should just be abstracted from the core game code. I really want to mess around with testing in Python. I haven't done a lot of nice testing in Python. I really want to try out some of the other testing libraries that they have. There's a built-in testing library for Python, but I want to mess around with like nose and some other stuff because I like writing tests because I'm a fool. And then moddable. That would be really cool. So what it would be cool is if it was composable, you could just have it be made up of, instead of me defining a player class, I can just define a movable and a damageable functionality. And then someone could come in and create like a goblin or something that has these attributes. It's damageable, it's movable, but it might have these modifiers. And so ideally everything will be loaded in through data files that people get in there and modify and then insert them into the game. And then some of the other roguelike stuff. So I'd like it to be able to have some random generation and some permadeath attributes and stuff like that. Cool. So let's come back here. And for now, like after I've said all these things, I'm going to ignore most of them and just go back to using classes for the first bit. But let's do it. There's a new thing in Python called a data class. Data class. I believe the way you use it is like this. So what it allows us to do is, instead of, well, let's just do it normally, and then I'll kind of come back and do it the other way. So what if we want to have a player that had a X and a Y coordinate and like a move function on it? So you'd have a player, you'd have def init, and it would have an X and a Y component. So self.x equals X, self.y equals Y. And it might have a move function or something, which just for the moment is going to do nothing. Great, so this is how you do it. There's a fair amount of boilerplate in here, like you have to pass in the X and the Y parameters set in here. I often have bugs where I set like the wrong thing or something. So this is kind of a bit of a shit way to do it. So the new hotness in Python is new player. Whoa. Which is going to be a data class. So it's going to use this data class annotation. And I'm going to have to look up the syntax because I'm actually forgetting now. So this is a new Python 3.7 feature. Data class, here we go. So it will add, basically, if I do this, and it also makes us do typing. So I can now go X is an integer, Y is an integer. If I remove this, these two things are actually functionally the same. So instead of having to have an init function where you pass it in and then self-assign X to X, this data class will just do that for you. It'll generate an init function that automatically takes in an X parameter. So I can now do player equals new player 10, 10. So they start at 10, 10. So it'll create an initializer that has two parameters and it'll set the first one to be X and the second one to be Y. You can kind of see here that it has typing built in. So we know that these are both integers. And what that means is that if I pass an ASD here instead of an integer, it'll complain because it'll tell me, hey, you said it's an integer. So it will still let me run this code because Python won't stop you from doing anything. But it's kind of cool that you'll get a warning about it and it'll tell you, hey, you've probably messed something up here. So it's got typing built in. What else can it do? It can do defaults. That's clearly not how you do it. There you go. So the new player will start by default at 0, 0. Obviously, I can pass in 10, 10, and they'll start there. Or if I could just pass in an X coordinate and let the Y coordinate be set automatically. So you can kind of see that it's just like there's nothing crazy about what this is doing, but it's just a nice way of messing around with Python syntax. It's a lot nicer to look at. Blah, blah, blah. It may also add some other stuff, but I'm not 100% sure. I think the main thing is that init. Oh yeah, there's also like weird field things you can do if you want to set them to defaults with lists and stuff. But I don't think that we're going to go into that. Cool. So post init setup. Jeez. Cool. So let's ignore the old way of doing it. Let's just create a player class for now. And in here, instead of printing hello world, I'll keep that. We'll say player equals player. 10, 20. And you can see we get autocomplete for all this stuff now, right? So it's going to tell us that it's gone now. I've made it disappear. There you go. So it's x, which is an integer which defaults to 0, and y is an integer which defaults to 0. So we can make them start at 10, 20. Print player. Oh yeah, the other thing it does is that it makes the printing really nice. So if I did that old def init one, then it would, by printing out by default, it'll look really terrible. Because I've made it a data class, it now has, when I print player by default, it should have like a really pretty printing style. Hello world, yeah, and we've got a player object where x is set to 10 and y is set to 20. So it just gives us like a nice print style through the repr method. Cool, so we've got a player that sits at 10, 20. This is obviously nothing, not even close to a roguelike in any way, but it's kind of just a cool example of, all right, well, how quickly can we get set up now that we've got Python going, to kind of show you some of the new Python 3.7 stuff with the typing and the data class. Oh, I do want to do, let's see, I wonder if I can do this f-string stuff. Is that how this works? The player is at. Whoa, cool. So now what this should do is print out the string the player is at and then player 1020. Yeah, that's cool. Cool, which you can kind of see looks really nice because now we can inject here and we can keep typing in here. Hello world again. So just a really easy way of outputting string in a bit of a nicer method. Great. All right. Cool. So that's done. So before I go and install like the actual roguelike library, which is going to give us the graphics window and stuff like that, I'm probably not going to do that until later on because I want to kind of separate the rendering from the playing, like from the actual game itself. So what I kind of want to do is do this as a bit of a test-driven first development thing. So instead of testing stuff out too much by playing the game, using tests as kind of the window into the game. So using tests to verify, does this functionality actually do what I want it to do, and so on. That's kind of a goal, at least. But for now, I won't bother doing that. I'm probably going to wrap it up there and just keep it short, as that will just be a kind of an intro one into like how do you install Python and pip and all this kind of stuff, set up a project, and then I'm going to come back sometime soon and do, let's actually start making this thing. Let's start making a roguelike and mess around with it. But yeah, hopefully that was useful to some people of kind of what is the state of tooling around packages and stuff like that. Thanks, Voodoo Kitten. Really appreciate that. Yeah, if you have any questions, if you're watching this on YouTube, obviously leave them there, and I'll try and get around to them. But it's kind of a confusing thing to set up a Python project, especially nowadays, where there's like 10 different ways of doing stuff. So yeah, hopefully that was useful. And then I'll come back sometime, probably in the next day or two, to do a stream on, yeah, actually getting in there and creating the first part of this roguelike. yeah, I got some cool ideas around it. The time travel stuff and doing functional programming and test-driven stuff is kind of something that's really exciting to me. So anyway, hopefully we'll see you there. And thanks for coming along.